Hello and welcome to Maths with Mr Amison. In this video we're going to be looking at how to find means from frequency tables. If you need to recap this topic then please watch Mr Chowdhury's video. I'm going to start by showing you an example, talking through it, and then I'm going to give you time to copy down the example and have a go yourself. Feel free to pause whenever you need to. Okay, so in this case, we had to calculate the mean age. You can see the data here is the age, right? And the frequency is how many people or objects have this age. It could be trees, could be whatever. It doesn't say, it just tells us how many have this particular age. So one person or thing has an age of 3, 3 of them have an age of 4, 5 have an age of 5, etc. So in order to calculate the mean from a frequency table, if we were to write this out as a list, we would write 1, 3, and then we'd write 4 3 times, and then 5 5 times, and then 6 5 times, and it's a lot. And if we were to add them together, then we'd have 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 5 plus 5, etc. So in other words, what we're doing is multiplying the 3 by 1. We're multiplying the data by the frequency to get 3, and we're multiplying this data by this frequency to get 12, because we'd have 3 4s in our list. 4 plus 4 plus 4, well that's 3 times 4, which is 12. So the first thing I did was I calculated the frequency multiplied by the data, which is called FD. And then when you find the mean, you add up all of your data. So frequency times data is the sum of all of the data for age 3. The 12 is the sum of all of the data in this row. The 25 is the sum of all of the data in this row, etc. So if we want to know the total of the frequency times data, that's the total number altogether. So it's a total of all of the ages added together, which is represented by the sum of the frequency times the data. This symbol here means sum, F means frequency, D means data. So the mean is the sum of the frequency times the data. And we divide that by the total of the frequency, because the frequency is how many objects or people or things we have. So the total amount of objects or things we have is 17. So in other words, we have 17 ages, and all of the ages add up to 91. So the sum of our frequency times our data divided by the sum of our frequencies will give us the mean. This formula is really important for calculating the mean from a frequency table. It's useful to understand what those symbols mean. Alright, and it's a quick way of writing it. So the sum of the frequency times the data divided by the sum of the frequency is therefore equal to 91 here divided by 17 here. And when we do that on the calculator, we get 5.35 to 3 significant figures. Take some time to copy this down and make sure you lay things out like I've done there, so that you've got a clear method in your books or in your notes. Once you've done that, I'd like you to have a go at this question. See if you can calculate the mean shoe size. Alright, so you've had some time now to have a go yourselves. If you have a look at this, then the mean, again, is the total of the frequency times the data divided by the total of the frequency. Or in other words, the sum of FD divided by the sum of F. Now FD is the frequency times the data. In this case our data is shoe size. So if we do F times D, our frequency times our data, 3 times 3 is 9, 4 times 5 is 20, 5 5 is 25, 6 3 is 18, 7 1 is 7. And then we want the total of the frequency times data divided by the total of the frequency, the sum of each of them. So the sum of frequency times data and the sum of the frequency, well, that's this. So the sum of the frequency times data will be 79, and we're going to divide that by the sum of the frequency, which is 17, which gets us 4.64705 or 4.6523 significant figures. Notice there's a link between these two tables here. I've just swapped the 3 with the 1 and swapped the 5 with the 3 to make this table here. In this case, you would expect our mean to be above 5, between the 5 and the 6 probably, because that's where most of the data is. And here we'd expect it to be just below the 5. And you can see that that is what we get. So you can sanity check your answers as well. That's a really useful skill to have. So time for you to have a go at some variety of questions yourself. Have a go at finding the mean in each of these. The green questions are the simpler questions. The orange question here, that's a bit more difficult. The numbers are a bit more complicated. Question 6 is rather challenging because you have to find the value of x here. That really is quite difficult. Have a go. So here are the answers to those 6 questions. We first do the frequency multiplied by the data to get us 0, 5, 10 and 15 here. And then we add up the frequency times data, and we add up the frequencies. And we always do the frequency times the data sum divided by the sum of the frequencies. 30 divided by 20, we get 1.5. And that makes a lot of sense because this is spread out evenly across all of them. The mean should be right in the middle, which it is, 1.5. In this case, you can see all of them are on the 1, so I would expect the mean to be 1 because they are all 1, so the mean of them should be 1. 0 times 0, 1 times 20, and the others are 0 because we're multiplying by 0. So if we add those up, 20, add these up, 20. So this 20 divided by this 20 is in fact 1, therefore this does work out to be correct. In this case, I've split the 20 frequency between the 1 and the 2. 1 times 10 is 10, 2 times 10 is 20, add them together is 30, add these together is 20 again, and you can see that we expect the mean to be 1.5 between the 1 and the 2. So 30 divided by 20 is 1.5, so it makes sense. This question here, we have more of our data at 3 than at 1. So I would expect the answer to be just above 2. So when we do the calculations, 1 times 5 is 5, 2 tens are 20, 3 tens are 30. Add these together is 55, add these together is 25. 55 divided by 25 is 2.2, so it makes sense. This question here, the numbers are it's just that the numbers are a bit more difficult. But in fact, you can see all I've done is I've took 2 from this category and put it in this category. I took 2 from this category and put it in this category. So in fact, I've left the spread of these numbers here the same as here. And when you do the calculation, 0, 2 is 0, 1, 3 is 3, 2, 8 is 16, 3, 12 is 36. You can see we get the same total here and the same total here, which means we've got the same mean. So moving 2 of these out of category and 2 of these out of category didn't change the mean at all, which is exactly what we'd expect. Question 6. This one is trickier. If the mean YouTube views is 5, find the value of x. So 3 is 1, 4 views is x, well, it was x times, 5 views was 5 times, etc. So when you do the multiplication, we get 3, 4x, 25, 12, and 28. Add these together, we get an expression, 68 plus 4x. We also get an expression here, 12 plus x. Because we know that the mean number of YouTube views is 5, what we can do is we can say that 68 plus 4x, this number here, the sum of the frequency times the datas, divided by the sum of the frequencies, 12 plus x, is equal to our mean, which is 5. So 68 plus 4x is equal to 5 lots of 12 plus x if you multiply both sides of our equal sign by our denominator of this fraction, 12 plus x. We can expand those brackets to get 60 plus 5x, because 5 12s are 60, and 5 times x is 5x. And it's just a case of solving this equation. We can take 4x away from both sides to get 68 is 60 plus x. And I can take 60 away from both sides to get the fact that x is equal to 8. So therefore this value would have to be 8 in order for us to have a mean number of YouTube views being 5. Alright, thanks for watching. I hope you found it useful to go over how to find means from frequency tables, and speak to you soon.